All right. So hello. So I'm DCBuilder. I'm a research engineer at the Worldcoin Foundation. Worldcoin essentially at TLDR is a project that's building the future of a privacy-preserving proof of personhood. So it's a way to prove that you're a unique person online, and also provides you a Sybil resistance guarantee where you're able to essentially prove that a given unique user has not done an action more than once, let's say. And today I'm here to talk about the future of digital identity. So this talk is essentially a distillation of an article I wrote in December of last year, more or less. And I've been thinking a lot about how digital identity is going to look like and what sort of properties we want out of systems that implement digital identity protocols. So to start, I want to introduce sort of what we have today, right? So today, the identity status quo of digital identity is really painful, it's really bad. We have systems, most of our data is in these like siloed systems, whether it's a Google database, whether it's Meta's database, whether it's like traditional websites or services that we use where we have to give up our data and our own personal information in order so that we can access different services and essentially use them, right? So the problem that we have nowadays is that we have to willingly give our privacy, and we're not able to do the things that we want in a permissionless way, in a decentralized way, and composable way. Like if I have data on like Meta, I'm not able to make a proof about that data and use it in some other application. I can only use it within the siloed environment. And also all of these platforms can just leak my data, right? Like they can get exploited, and my private information can be leaked, whether it's like my medical records or whatnot, right? So as I mentioned, right, so current identity systems, siloed SQL databases, right? They're permissioned, they lack interoperability. They're security vulnerabilities in the sense that they're honeypots for people to exploit and export private data from different users and then trade them for profit, right? Like people trade our data so that advertisers have more targeted ads and all those sorts of things, right? It's privacy invasive. If you want to, for example, like gatekeep certain applications through KYC or KYB, you cannot do it because now, like with the advent of generative AI, you don't even trust most documents because like you can fool things like KYC processes nowadays. It's centralized, and the user lacks sovereignty. So essentially, in the last couple of years, I'm sure many of you have seen that there's a whole new advent of new cryptographic primitives that are really, really useful. Specifically, I want to mention 4 of them. So we have zero-knowledge cryptography, where I'm able to prove something, a property, about a given statement that I have to somebody else, right? So you usually have a prover and a verifier, and I, as the prover, I have some claim I want to make. I can prove to you that I'm over 18. I have a personal passport with a digital signature. I can prove that I have a signature from a government entity, that my name is DCBuilder, for example, whatever. So another one is fully homomorphic encryption, or FHE for short. FHE is a type of cryptography where if you encrypt some plain text or some input, you're able to perform computations on top of that input. And when you decrypt the ciphertext, you essentially get the operation performed on top of the original input or plain text. Multi-party computation. Parties are able to compute some computation together in a private way where participants don't learn the entire secret, and they're able to do it in a fairly nice way where you get verifiability in the end if you trust the MPC protocol. And the last one that I'm mentioning is trusted execution environments. So trusted execution environments is more of like a hardware solution. So essentially it's this chip that signs everything it computes, or this virtual machine environment that signs everything that happens inside of this hypervisor or virtual machine environment. And essentially, if you perform computations inside of this environment, you get some trust assumptions from it. Like you can verify that something was indeed executed in this execution environment. So thanks to these primitives, cryptographic primitives, and their derivatives, people have started building different protocols with them. And we've seen a mechanism design explosion. So what does mechanism design mean? Essentially, it means that now developers have more room and more freedom to build different interesting products and protocols and tools with the technologies that I just described. So some of them are these that I mentioned in my article. So to just go over them briefly, if you want, I have a link to the full article that explains each one in detail with examples. But just to explain each one briefly, so ZK email is developed in conjunction by the ZK email team, which is like Ayush Gupta and a bunch of people from the Privacy Scaling Explorations group at the Ethereum Foundation. And the way that it works is that you're able to prove email keys. And you're able to extract information about emails, right? So if I receive an email from, let's say, my friend Ben, for example, my friend Ben sends me an email, I can prove that the content of the email sent from Ben's email server is, I don't know, hello, DC, how are you doing? Right, so this is useful because now we're able to prove information about our emails. And people have already built applications like zero-knowledge peer-to-peer, ZK peer-to-peer, which is a marketplace where you're able to trade dollars on Venmo and claim dollars on the chain by verifying a Venmo signature, where Venmo sort of verifies or sends you a signature, an email confirmation that somebody has sent you money on Venmo, essentially. So like peer-to-peer marketplaces, for example. Another one, ZK Login, developed by Miston Labs, the guys who built Sui, essentially allows you to control a EOA or any essentially address using your traditional login authentication provider, right? So I don't know how much you're familiar with like things like OAuth or traditional authentication methods like Google, sign in with Google, sign in with Meta, those sorts of things where you see pop-ups. So now what you're able to do is you're able to create a zero-knowledge proof of your signing with Facebook, signing with Google, signing with anything that you have. And using this ZK proof of this, you're able to control an on-chain address. So it's a good tool, for example, to bring users from Web 2 to Web 3, in my personal opinion. Some other ones like TLS Notary and attestations, right? So TLS Notary essentially allows you to extract data from internet sessions, like web sessions. If I'm connected to a website, I'm able to extract information from it. I can prove to someone that I, for example, have listened to 10,000 minutes of Taylor Swift on Spotify, for example, right? And I can make proofs about all of my internet activity, as long as the server is not lying, right? Like the trust is put on the server that I'm making proofs of. But we mostly trust the data that we get from things like Spotify and other sources. So that's sort of like a really important protocol to extract data from, and it's part of our digital identity as well. Proof of personhood, right? Worldcoin, for example, for proving that you're a unique human being and that you've not done action before. Rate limited nullifiers, it's a way to essentially do Sybil resistance, but with a cryptoeconomic stake instead. Minimal anti-collusion infrastructure. So this is a protocol that Vitalik proposed a couple years ago, which essentially allows you to do voting in an economic sense where each participant in the voting mechanism has an incentive to not collude with other participants. Attestations, right? So attestations is if I make a statement about something, right? I can make an attestation that, okay, I believe you're trustworthy. I believe that someone is a good cryptographer. That is an attestation, essentially. I make a statement about X. And currently, attestations are not very trustworthy. If I say something without backing it up, there's no really good way to prove that. But we have data now, right? Like we have on-chain activity. I can make a statement that my on-chain activity is trustworthy, right? I can make a proof that I've interacted with the protocol and that I've done so many transactions and that my financial history is good and reputable, et cetera. And that's an attestation that is useful. Web of Trust. So Web of Trust is more of like attestations, but in a social context where people sort of signal trust across each other and they can build trust networks in sort of like a social graph environment. ZK KYC, ZK coprocessors, proof aggregators. Essentially, all of these new tools that we've been building for the last couple of years allow us to extract information and allow us to make proofs about that information and consume them with very few trust assumptions. Essentially allow us to decentralize data and make statements about them. So why is this useful? And how might this even look like in terms of the real implementation in the real world, right? So this is sort of like hinting at how I see the future of digital identity currently. In my framework, the way that I see things is that we start with some data, right? Data is the most important thing. It can be in all sorts of different places. It can be data that's stored on my phone. It can be my personal, like, digital government identification. It can be on-chain data that I have. It can be data from websites, from databases, from any place, right? I can somehow extract a provenance proof. I can prove to you that this data came from somewhere. It came from Facebook.com. It came from my phone because the phone signs the information that I create. It came from my digital passport because my government's publicly signed the information that I have on my passport. Right, we have data and data provenance proofs. Once we have that, we can extract the data and put them in a general programmable environment, such as a ZK coprocessor. So we've seen things like the RISC-0, we've seen things like Axiom, we've seen things like zero-knowledge virtual machines, right? Like all the rollups and such and such. And what those are able to do is essentially you're able to make statements, or you're able to make essentially general computations. And I can take that data and put them into this programmable environment, and I can do anything with them. I can combine them, and I can prove to you that, hey, I'm over 18, I come from this country, I've interacted with Aave 1,000 times, I've done so many and so many things on this website, I've used Spotify for 10,000 hours. All of these things, we can put them in this environment, we can make these statements, and it's something that's really, really useful. Something that we've seen also recently is that it's really hard to combine these proofs and this data from lots and lots of different sources. So that's where sort of proof aggregators and proof marketplaces come into play, where people are able to design systems in which they're able to combine heterogeneous proofs, right? Proofs from different kinds, from different places. And another problem is that if you, for example, want to make a complex statement, it's really, really hard as a user to just go to all the places where you have your data and then put that data into some general programmable environment and do everything yourself, right? Like in the imperative design, where I, as the user, have to do everything, it's very cumbersome and the friction is very high, therefore people would never do it as opposed to just using the existing systems. So maybe you've seen things like intents recently, where intents essentially is the declarative way of doing things. I just say the end result, and someone figures out how to solve the problem that I have at hand, right? I define that, hey, in the context of DeFi, for example, I can say that, hey, I want to sell ETH at $10,000 a piece. And some solver can just fill that order once it's profitable for them, for example. So in the context of digital identity, an intent is essentially a user says, hey, I want to convince this website that I can access it because I meet the requirements. And some solver or some party is able to figure out what are the parameters that I need to fix or I need to do or meet in order for me to be able to use that service. So essentially, they're able to construct the circuit or the proof that I should do, and I, as the user, only do one signature on my personal client or my app or whatever, and I just fill all the data and the provenance proofs, and I feed them into the circuit or the proof or the attestation that the solver created, and I'm able to consume the attestation within the app that originally requested it without me ever having to care about how it's constructed. I just sign once and it's done. And it's a lot better user experience than currently we have with traditional experiences in Web 2. And last but not least, I think something that's really important, especially nowadays, is provable inference. So in the context of machine learning and AI, we've seen that intelligence is becoming a really important commodity. And we want to make reliable predictions, we want to make inference, we want to use the data that we have and the attestations that we have to solve problems, to solve our own problems, to have better lives, to be able to do cool things. And so another thing that I think is going to be really, really important in the advent of AI is that we are able to get proofs about machine learning models and what they do. So using zero-knowledge machine learning, we're able to do such things. There's many teams building it. Some of them are even in our crowd, like Giza, for example. And essentially, we're able to make proofs that some machine learning algorithms performed computations correctly on top of our own personal data. And everything can happen client-side. Like, as the user, I don't reveal any private information about myself, but you know that this machine learning algorithm ran correctly and solved all these problems, right? We can automate this digital identity pipeline thanks to machine learning. So where does this all lead? What is the future of digital identity, in my opinion? So as I mentioned before, the identity status quo sucks. It's very invasive, it doesn't scale, people own our data, they make money off of us, they make profit because they serve as ads so that we can access their services, they're not decentralized. If I want to change a piece of code of the services that I use day to day, I cannot because I don't have access to the code because it's closed source. I don't know how to verify it, I don't know if it's secure. People can leak my private data and trade on the private markets. They profit off of it. And you as the user, at the end of the day, is disadvantaged in every single aspect when you're a user. So that's why we're here. That's why we're building crypto. That's why we're building Web3 in the first place. We've done it first for financial assets, right? Like now we are able to transact freely. We're able to do transactions without anyone being able to censor us. We're also working on privacy, right? There's also solutions that are trying to give it private. But now we need to do the same thing for data, for our own personal data, for digital identity in a way that it's scalable and unlocks a huge wave of value creation for society. And the properties of such a future are the ones that I list, right? So like it's decentralized. There's no single system that can be just taken down and we lose access to everything. Let's say I'm a YouTube content creator. If I spend 10 years creating content and out of nowhere, like I've made like my entire livelihood is dependent on the videos I make, YouTube just decides to censor me, I'm no longer able to make a living. And I'm not able to export my social graph out of YouTube. I'm not able to use an alternative platform to do my livelihood. Right? So this is such a system, right? Like you want it decentralized, permissionless, censorship resistant, right? I don't want people to be able to take my identity away from me, even though I'm still the same person. It's just the platform is censoring me. In a future where we're overly dependent and getting even more and more dependent on digital assets and digital identity and systems, you want to have self-user sovereignty. We care about like individual freedom, right? That's why we're Westerners essentially. We care about individual freedom. So we need to build systems that preserve them, right? So we need systems that are decentralized, self-sovereign, privacy-preserving, scalable, right? Also, if we build systems that nobody can use because they're too expensive, what is the point? We want something that anybody can use, that the entire planet can use. They need to be interoperable and composable, right? If I create something on one platform, I want it to be useful in other platforms. Come on, like we don't need vendor lock-in like we have in traditional worlds. People want to create their own silos and they want to take users and they want to help them stay in their own ecosystem so they can make profit off of them. That's the problem. I think that we need to create systems that have no lock-in. It's just some protocol that I can choose to use, and when it's no longer useful to me, I can opt out and just use something else. And I never reveal data that I don't want to reveal. It's always self-custodial. I own my own data, and I make proofs about it. And I show to the people only selectively things that I want to expose. Right? There's no honeypot, there's no single point of failure where people can extract all of my personal information, steal my identity and do things in my behalf, or censor, or essentially make my life miserable in any way, as we have currently. Incentive alignment, of course, this needs to be economically viable. You need the infrastructure and the technology to be sustainable. If somebody is providing a service, it needs to be paid for with a margin so they can also make a livelihood. Otherwise, capitalism essentially would not work. And the last and not least, it needs to be open source and community built, right? We don't want huge, gigantic companies that have no vested interest in our own well-being to essentially build everything. Currently is the most efficient way to do it because it's hard to coordinate people at scale when you don't have transparent incentives and when there's no trust. People don't trust each other. That's why we've created essentially entities. We have companies, we have governmental entities so that we can build trust. We have a legal system, so we have trust. And there's no other way to do it currently, but that's why we're building crypto, right? Like we are able to make proofs, cryptographic proofs, so that we can get rid of traditional legal system trust and replace it with math. We're able to just verify mathematical statements and trust each other through that, as opposed to trusting like some legal system enforcing the rules that some other people agreed upon. So that's essentially my talk. It's a summary of the future of digital identity blog post that I wrote on Mirror last December. Feel free to scan that QR code. If the QR code is outdated or doesn't work, just go to DCBuilder.mirror.xyz, and you're able to just look it up within the articles that I posted recently. And if you want to send me a message or ask me something async, if you don't want to ask me in person now, or you want to just ask something else, feel free to follow me on Twitter or X at DCBuild3R, or send me a message on Telegram with the same handle. Thank you very much, and thank you for listening. Yep, yeah, I'm ready for Q&A. Yeah, if you want.
Hi, DCBuilder.
Hello. Right, so the question is, if I understood correctly, is how do you prevent censorship when it comes to AI, right? So currently, as you may have seen, like you have things like OpenAI with ChatGPT, you have Google, you have all these AI providers, and they have their own trained models. Some of them are closed source, some of them are open source. But if we become overly reliant on these models to do our daily tasks, we may be able to just get censored by these platforms, and we don't have access to this enhanced selves that we maybe get accustomed to in the future. So how do we prevent that? Well, just we do the same thing we've done with crypto, but with AI, right? We create foundational models that are open source, decentralized, and we allow people to run them on infrastructure, and we create marketplaces and incentives for people to operate them for us, right? or we can also just self-host them, right? I am able to build my own hardware to operate like this hardware, like this AI model on my own local machine, for example. Or I can just have some infrastructure that is decentralized that I can always query and maybe request a proof from them, right? If I don't trust this platform that they're giving me the right model or the right inference, I can just tell them, hey, can you please create a zero-knowledge proof that, okay, this is indeed the model you're giving me. So I have no added trust assumptions. And crypto is also really good at creating incentive alignment, right? I'm able to pay them for the service that they're giving me in a very efficient way. I don't have to wait for Stripe to like process a payment. I can just pay my neighbor who's running a rig, who's running a local model, and nobody can stop me because the blockchain is censorship resistant in design, right? So this is sort of like how I'm currently thinking about that. Right. Okay, so the question was, if the model is open source, how do I prevent the data being essentially somehow spoofed or made bad or incorrect? So if the model is open source, it depends also how training happens, right? How do I have verifiable training, or at least I can trust that the foundation model is performant? I think currently the best way to do that is just benchmarks, like having open source benchmarks. Like if someone publishes an open source model, I can have a really sophisticated benchmark pipeline that I can use to test whether that model is good, right? And that is not biased. Like there's anti-bias tests where like I give them some prompts and I see the responses. If the responses are good, then we can create some pseudo efficient ways of checking whether a model is correct or not, right? So if we have these open source models and we have open source benchmarks, we can just download them locally and run them locally, or we have essentially third parties running them for us and giving us proofs that they actually ran the ones that are open source. Because if they're open source, they can just create a zero-knowledge proof without hiding the model, right? Like they can keep the model public and just give us a proof that they indeed ran the model that we want. Okay, what is your question?
Recently been hearing that certain developing countries are interested in ZK-proof-based identity infrastructure. How do you see this playing out in the near future?
So usually what I've seen is that a lot of developing countries don't even have governmental systems to begin with. They have skipped the entire process. Like we as developed societies, we had these governmental entities since the beginning of time. Like thousands of years, we've had governments and entities that give trust in our societies. Some of them have never had this. There have been like very sporadic tribes or small groups of people, or even like a country with entities that they cannot trust themselves. Like it can be the government, but I don't trust the government because they have always like done things against me. So how do I think about digital identity in this context? I think that now most of these people have access to phones and internet access, right? So they're able to build their digital identity even without having some centralized entity attestating for like their personhood or whatever, right? So currently I think that the best bet for them is to somehow bootstrap like a network of users for them where like they have access to internet and they're able to create zero-knowledge proofs on the client side. One of the biggest problems that we've seen is that zero-knowledge proofs are optimized mostly for running on servers, on beefy machines, because we've seen things like blockchains, private blockchains, or scalable blockchains, roll-ups. All these sorts of things require server-side proving with machines that are gigantic AWS instances, et cetera, et cetera. So how do we create zero-knowledge systems and infrastructure that is able to run on clients, essentially phones that are in like developing countries? They're very non-performant phones, maybe 1 gig RAM max, 1 core sequential from like 2013, 2014 phones, like $100 phones. The question is, look, we already are doing that within Worldcoin. For World ID proofs, you can generate like a World ID proof. It's a GROS16 proof. Client side, very small. It takes like a couple seconds for a user to generate that. So for things like proof of person, it's already there. Like we can already run it on really low-end hardware, cheap hardware. For this future of digital identity, it's still going to take 5-10 years minimum, because not even the modern phones like my iPhone 15 Pro Max or whatever, it's not able to create a zero-knowledge proof because it doesn't even have a ZK chip, and all the ZK systems are not standardized yet. So even chip manufacturers don't have an incentive to build something like an ASIC, which is optimized to run ZK proofs client-side, because first of all, there's not enough value. The market is really, really low, right? Like small. There's not a big incentive for companies because there's not a lot of use cases. So we need to build use cases, adoption first, and then sort of incentivize manufacturers to build chips that make zero-knowledge creation or zero-knowledge proof creation really cheap on the client. And then we can enable this sort of future that I described in the article. Yeah.
So we have time for one more here.
You mentioned using stuff like FHE, you'd be able to prove that, for example, you listen to a specific song on Spotify. How would you say for existing closed source services that don't have these cryptographic primitives implemented, how would you go about bridging either ZK proofs or
Right. Perfect. So how do I make proofs about things that are closed source? So things like Spotify and all of these services that we're used to, websites, all of the websites that we use and the services that we use, like 99% of them, like if you look at your phone and the apps that you use, you don't really know what's running. Like you don't know the compiled code, you don't know the code that you're actually running on your phone. You're just trusting the vendors, of course. So the primitives, actually, let me just scroll back a couple times if it still works. Should work, okay, awesome. So in the set of primitives that you have, some of these primitives allow you to extract information from closed source things. You're still trusting the website, right? Like if I make a proof about information that is on Facebook.com, Facebook.com can intentionally lie to me. Like I cannot prevent that, but at least we have tools that allow us to extract information from them in a verifiable way, right? So if we at least trust that they're not going to violate the APIs or they're not going to like be adversarial in terms of like providing services, and we're able to extract information from them, then you can use things like TLS Notary. You can use things like zk-TLS, which is not on this slide. Essentially anything that allows you to extract information from the information that you're sending from the server back and forth, right? Or also the things like zk login, or zk email. I'm able to make proofs about my email. I'm able to make proofs about the websites that I use. So these are sort of like the things that are going to be like the Web 2.5 of digital identity, like us extracting information from Web 2 native places so that we can use them in Web 3 native places. And that process is going to take a long time because people and the adoption, like the applications that have billions of users are Meta, Instagram, WhatsApp, all these things are the things that have users. So we need to create flows that are better, but we also need to give them the benefit of the doubt. Like if I want to use Google to interact with my dApp, they should be able to do so. And eventually, the dApp will use crypto-native primitives that are a lot more user-friendly than even the Web 2 primitives to begin with. So once the user just is sold on a product that is easy to use, I think like that's how we're gonna like transfer them from traditional applications. Yeah.
Awesome.
Okay, thank you.
Thanks so much.